Today we are going to discuss the topic about construction of three-phase induction motor. The electrical machines at a electromechanical energy conversion device. Electrical motor converts electrical energy into mechanical energy and electrical generator vice versa. Most of the industrial load are inductive, especially three-phase induction motors are widely used in industrial application and continuous applications. Principal operation. These three-phase induction motor extensively used for electric drives. Advantages of induction motor is simple and rugged construction, high reliability, low cost, high efficiency, require less maintenance. The rotating magnetic field of is set up the stator three-phase supply is given. The stationary rotor cut in the revolving field due to electromagnetic induction of EMF is induced on the rotor conductor. As the rotor conductor is short circuit current flow through the circuit. It becomes current carrying conductor, magnetic field and start rotating. Slip of induction motor. Induction motor always rotate a speed less than synchronous speed. The difference between flux ns and rotor speed n is called slip. So S equal to ns minus n into 100 divided by ns. Ns is synchronous speed and n is equal actual speed. Slip speed is equal to ns minus n. Then image of three-phase induction motor. Then cut in the wave of three-phase induction motor. It has two construction parameter. One is stator and another one is rotor. Stator is a stationary part and rotor is a rotating parts. Component of three-phase induction motor. Induction motor consists of two major parts. One is stator and another one is rotor. Stator. The stator is made up of number of stamping with attempted slot and tooth. The stamping are insulated from each other. Each stamping is 0.4 to 0.5 thickness. Number of stamping are stamped together to build the stator core. The stator core is fitted in casted or fabricated steel frame. Three-phase winding is called stator winding. It may be connected either star connection or delta connection. Frame. Frame provides mechanical support to the stator and rotor. It is made up of casting material. Rotor. There are two different types of rotor circuits. One is squirrel cage induction rotor and another one is slip ring induction motor. Squirrel cage induction motor. This is made up of cylindrical laminated core with slot to carry the rotor conductor. The rotor conductor are heavy bars, copper or aluminum stud. Circuit both ends by end rings. This rotor is called a short-circuited rotor. Rotor resistance is very small. External resistance cannot be connected to the circuit. This is the component arrangements of three-phase induction motor. Bearings and casting, short circuit rings, stator winding and stator and mounting plate. Winding. There are two types of winding. One is star connected and another one is delta connected. And rotor winding. It's a wound rotor bar short circuit the both ends through the end rings. Three-phase induction motor. Already I discussed about there are two types of induction motor. One is squirrel cage and another one is slip ring induction motor. Squirrel cage. The squirrel cage induction motor, copper bar embedded in the rotor slot shorts both ends end rings. Simple, low cost, robust and low maintenance. Wound rotor type. Rotor winding wound by wires. The winding terminal can be connected to the external circuits through the slip rings and brushes. Easy to control, speed and more expensive. And Slip ring induction motor. In this type of rotor winding are similar to the stator winding. The rotor winding may be stator or rotor or delta connected or distributed winding. Wound for as in many number of applications of whole stator. The three phase are brought out and connected slip ring mounted by the rotor stab. External variable resistance can be connected to the rotor circuit with the help of braces and slip ring arrangement, varying the external resistance of rotor circuit with speed control. Thank you.